Hey guys, I'm in Mammoth right now on a little weekend getaway, but I wanted to take a little moment here to make a little tutorial to make this lab as easy as possible. It involves Fiji again, and so it's a little bit more technically challenging, so I want to anticipate the questions that might come up. So um, basically, this is a lab about conservation of energy and how some predatory birds, especially seabirds, will use potential energy to gain enough kinetic energy slash velocity to be able to hunt birds in water. Okay, and so um, we're going to actually kind of use videos of these birds doing this to kind of prove that conservation of energy is real. All right, so go to Fiji, open it up on your computer. Hopefully, most of you still have it. If you don't, there's a link to download it in the original lab that we use Fiji in. I think it was week 3. And so you can go here to File, Import AVI, and you want to go to Canvas and download the birds video. And as long as that's downloaded, you can just go to your downloads and then click your birds, right? And then click Open, and then click OK. And you have this really, really cool video, and I'll advance it here, of these birds diving into the water, right? Cool, huh? And they they all are going to be gaining velocity due to gravity, right? Their potential energy up here is going to turn into their kinetic energy when they hit the water, okay? So you want to go to the plugins, same one we did last time, this manual tracking. So go to tracking, then go to manual tracking, okay? And then we want to add a track, all right? And then I'm going to just get the first bird that comes out here, okay? And these guys are roughly a meter long, okay? And so we want to be able to calibrate the little tracker in here so that it knows. So right now it only knows the amount of pixels that are between any two given points. But those pixels have to be able to be converted to an actual distance, right? So that when you do distance divided by time, the program can actually record a velocity, right? So the way we do that is we pick this point, like at the tail, at the very beginning of one of these birds. So I'll pick this guy, right? And so you see it has an XY coordinate of the pixels at that point, all right? So in other words, this means that this is 1130 pixels in the X direction and then 44 pixels down in the Y direction. That's what that means, okay? And now I can pick the next point right at the very tip of the gannet. That's the bird, that's the name of the bird, right? And now you can see that I have a second set of points, okay? Now the cool thing is, so that was here to there. Now we can just use the distance formula, as I state in the lab, to find the actual distance between this point, this XY coordinate, and this XY coordinate in pixels, okay? And because we know that whatever distance we get in pixels, that has to be 1 meter, we then have a conversion between pixels and meters, all right? And so what that means is I can close this. I can say end track, okay? Actually, you might as well just delete all tracks, okay? And then I go back to show my parameters, and I pick just unit, right? Knowing that unit is meters. I'm deciding when I say pick unit, I'm saying it's meters, okay? And then we can put in our XY calibration, whatever we get for it, right? Let's say that we found out that it turns out that that 1 meter is, I don't know, let's say 120 pixels. I'm putting something totally random in there because I want you guys to actually calculate it yourselves. And then you have to use the frames per second, as I say in the lab, to find the time interval. But I'm just going to leave that there as 2 seconds. That is not the right answer, but you'll have to calculate it yourselves in the lab. Okay, and then I'm going to go ahead and now add another track. Okay, so now check this out. There will be a bird comes out, okay? Let's just take that first bird, for example, okay? And now I can start tracking him or her, could be a ladybird, and I'm going to track this bird all the way until it crashes or splashes into the ocean to get its little prey. Okay? So keep tracking it all the way down. Okay, so it's about there, right? And so you'll notice that this guy starts actually tracking the velocity for you, right? It's giving you the velocity of this guy as it goes down. So you can compare the first velocity that you get, right, which looks like it's 1953, and then you can compare that with the last velocity. And now we want to take an average. So it might be best for you to take the average of these last three, just in case, because it's a little fuzzy where it actually crashes into the water. So to get accurate, I would take the average of these last three, and we'll see that the average of this guy, and this guy is certainly going to be more than this. In other words, gravity has accelerated this bird as it crashed into the ocean. And you guys want to use these velocities to prove conservation of energy. Okay? So that is my tips and my hints for the week. Good luck. If you get stuck, try to work through the challenge, reach out to each other, and if you get truly stuck, then you can reach out to Professor Crockett or I. Okay? All right. Good luck, and I'll see you guys this week.